we have completed 6 weeks of this course, and since this is a 12-week course, this is the midway point. We have now encountered all the main components of information theory. We have seen Shannon entropy as a measure of uncertainty, and to justify this as a measure of uncertainty, we show two different applications. Shannon entropy came out as an answer to a compression problem. It also came out as an answer to the answer as a measure of randomness in the random variable. Then we also saw total variation distance, a notion of distance between two PMFs or two distributions. And in particular, we saw that this total variation distance also comes out operationally as operationally in terms of this binary hypothesis testing problem. In particular, a Bayesian formulation. The total variation distance is related to the minimum probability of error for a binary hypothesis testing problem with uniform prior. In fact, what we saw was that if two distributions are close in total variation distance, then it will take then the probability of error for distinguishing between the two of them is higher. So that means it's harder to distinguish them. So distributions which are closer in total variation distance are harder to distinguish. Next, we saw this notion of Kullback-Leibler divergence, the third main character of this course. Once again, we saw it as an answer to a binary hypothesis testing problem. In particular, something called the Neyman-Pearson formulation, which we defined. And we showed that the probability of error of type 2 can go to 0 exponentially in the number of independent samples that you have, provided you require a fixed probability of error, or provided you have an upper bound on the probability of error of type 1. The probability of error of type 2 can go down exponentially. And this exponent is exactly this Kullback-Leibler divergence. This is Stein's lemma. We didn't show it, we just showed one side of it. We didn't show that this is the optimal exponent. We'll show it later in the course, but at least it brings out this quantity called Kullback-Leibler divergence, a second notion of distance. Next, and finally, we define this notion of mutual information, which is the information revealed by Y about X. And we define it as the change in uncertainty. So the uncertainty in X before Y is revealed is H of X, and the uncertainty in X after Y is revealed is the conditional entropy of X given Y, and this change in uncertainty is the mutual information. In fact, from the formula that we obtain, what is very interesting is that we saw that this mutual information is exactly equal to the divergence between the joint distribution of X and Y and the product of marginals. So mutual information captures how far is your distribution from an independent distribution. So independent distribution, the random variables X and Y have no correlation, and they're uncorrelated and they're actually independent. And the actual distribution, how far it is from this independent distribution, captures the amount of randomness. Alright, and we also roughly saw through Fano's inequality how this mutual information controls the probability of error for an Emery hypothesis testing problem. We'll elaborate on that later again. Then once we had these four quantities, we saw various properties of these quantities last week. We saw the chain rule, which allows us to divide randomness or information into small chunks, into bits, let's say. We saw various properties of these functions. We saw that these functions are all non-negative. They can be convex or concave. For instance, entropy is concave. Then finally, we also saw the data processing inequality, which applies to, we saw two forms of data processing inequality, one for these distances and one for mutual information. So in short, we have covered all the basic components of information theory, and we can now accelerate and move faster. So from this week onwards, I'll try to put out more content per week, so that we can move faster. Since now you have all the basic notions covered, you can, I guess, follow easily what I'm saying. So we'll move faster starting from this week. This week itself, I'll have 2 units instead of 1. So I hope you enjoy this. See you in the next video.